Heard you talking about part of the process yesterday during stand-up from the interview.
Oh yeah. So I could have gotten better. Let's put it that way. But so the first interviews, he gave me a code problem, and it's basically the problem is so their system. It's a network of satellites, and you have to maintain the clock across the satellite system. So, so for any given flight controller, the satellite clock's essentially coming in as an interrupt. So it's an interrupt, and then that ticks the clock. So you're maintaining the clock, but the interrupt comes in whenever, right? And then you call, one of your functions will call that the clock and see what it is. But how do you know that, how do you know that during the process of calling the clock, the function you have to call the clock, you didn't get the clock, and so now you've got a mismatch in your output, right? So you have so it's like, I don't know.
Like lots of different pieces to think about and tie together. Yeah.
So you had to write a couple functions. Like one was just to well, how do you tick the clock? Well, the thing is, it's a 64-bit clock and a 30-bit 2 operating system. So how are you ticking the clock? Or how do you handle that? And I can write that as basically create an array of the upper 32 bits and lower 32 bits, and you tick the lower, unless it overflows, and then it ticks the upper, resets the lower. That was pretty straightforward.
Nice.
But then the actual function when you call the clock, the handling of I didn't get that one. You can't wrap your head around why this is important. It doesn't happen very often. Call the clock during when the interrupt comes in.
Yeah.
So maybe you just need to block that function during the interrupt.
Mm-hmm. Or yield to something else, so to speak. Yeah. That's interesting. Yeah, I like problems like that.
So so it's like asynchronous. You got to think about an asynchronous system, which is not really something where we'll think about that all the time.
Yeah.
Handlers, event handlers.
Yep.
Event handlers we're implementing them here essentially.
Right. Yeah, they're kind of just like they're waiting, they're listening.
Yeah. So you're not locked in. You're not locked into synchronous code because then you can't hear your event handler.
Exactly.
It's like, are you multi-threading at that point? I'm not sure. I don't think so.
Yeah.
Kind of.
Yeah. See.
That's the thing with all these interviews I've been on. It's like it always comes down to the code problem.
Mm-hmm.
It's just for hardware. It's like you gotta have the code skills.
Yeah, it's one thing to think about the problem, but then it's another to actually kind of write it out. And they want to see both. It's good to get the occasional person that can just start going and just diving into a problem. But more often than not, they love to see someone really think about the problem, from a large overall standpoint, really get their kind of see how they're really thinking about it before going into it. They really appreciate that too.
I think they actually like that more than just going into the problem.
Mm-hmm. Yeah, exactly. Okay. Get started talking about typography. So let's talk about typography. But before we talk about typography, what the heck is it? What are your thoughts? Font? Anything specifically Anything specifically related to font? What about an image like this? What's the difference here? Let me ask this. Which would you prefer to see on the highway? Why is that?
Very clear.
Mm-hmm.
Nice block letters. White space between the letters.
Yeah.
In this case, black space between the letters.
On the highway, there have been some considerations made for us as the driver in that the text is the important piece in this case. We're more concerned with the content, we say, than the aesthetics. So it's the utility that counts here. Now, if we were in a smaller town and kind of visiting, and we see like a sign that points to some tourist attraction, typography might kick in there, where we actually kind of get some design properties to pick up on, make it a little bit more interesting. But in the sake of not only time and safety, we prefer text in this case. So we say that typography is the visual component of the word, and it's more concerned with the arrangement, the style, and the presentation of its type. And visual component of the written word, and that covers very specific details that we will showcase here. All right, so what? Why do we actually care? Really though, why does this matter in the everyday world? Why does typography make such a big impact in our everyday lives?
It actually makes people feel things.
Mm-hmm.
There's, if you look at something, look at, like me personally, if I'm looking, I pick a certain font because that certain font makes me feel better.
Yeah.
That's the only reason I pick it.
And even beyond typography, what about like certain icons, right? If you see like the swoosh, that's Nike. If you see the golden M or arches, McDonald's. If Codefellows tomorrow changed its font face to look like Google's, you'd pick up on that immediately. So typography has very, very huge impacts on branding and recognition. And as JP mentioned, also kind of the overall feel of how something looks. So it's definitely about the utility, the legibility, and the design. So here's some technical vocabulary when we speak about typography. So the typeface is the actual font family, but the font itself is the subset. And there are other pieces too, more technical pieces that you can really dive into that most people don't consider when they first start looking at text and typography. So looking at this chart, you can actually get a really good look at what the different pieces, how they come together and how they play along with one another. Note that the mean line or the median is essentially just the halfway point between the base and the cap, and that could change actually dependent on the X height, because we see that some of the lowercase letters are rounded. But that kind of gives it a nice visual feel to it. So check this out. Which is which and why? We see serif and sans serif. Right hand sans serif, left hand serif. So we say the serif typeface have the little strokes at the ends of the lines, and the sans serif typefaces do not. And if you break that down, what does sans mean after all? Yeah, French for without. Oops, I shot the serif. But it's okay because you can still read it. So translation between print and web fonts of the same design, they will differ slightly. Fonts designed for web are often modified and optimized to enhance readability. And including a web font looks something like this. Does this look familiar? Have we seen this in our code base? So notice we have our font family, which is called My Web Font. With IcoMoon, they had a name in there as well. And when you declare with the font face declaration, the font family name can actually be whatever you want it to be, but it just needs to be consistent. But this is a typical declaration where you can see your source font files and the different text formats within those files, and even getting down into like different images in the case of IcoMoon. And here's an example of font stacking. So what do we mean by font stacking?
If you don't have this one, check if you have this one down the line.
Yep.
To serve.
We start with the font that we want to try to incorporate first, and if that doesn't match, then we kind of move along down the line. If there's one type of font that's not supported, then we can move along to the next one that may be supported. What's going on with the quotes? Why do we have some that are wrapped in quotes and some that aren't? What was it? Yeah. So we have to account for the spaces in this case, which is a safe thing to do. It's not always guaranteed to break, but it's typically standard to wrap anything with multiple words or spaces in quotes. It's good to take note of. Here we see the differences between self-hosted versus hosted. So by self-hosted, we just mean something that we already have access to versus something that's available. Has anyone used Google Fonts before? So those are pretty handy. Has anyone ever tried to make their own font? It is quite the challenge to be able to do so, and people pay really good money for customized fonts, and people pay subscriptions for some of these fonts, and we're talking thousands, sometimes hundreds of thousands of dollars over the course of a year. Because again, this is going back to, if you're talking in terms of businesses, you're talking in terms of brand identity and awareness. That's it's worth it for them to pay the money to do that. So definitely use fonts that you are allowed to have access to. I would encourage, if someone's actually requesting a font in any kind of client work, if they're looking for a font that's going to be or is potentially looking to be very expensive, I would definitely encourage you to research alternatives such as Google Fonts. Most of the time you can find a really good matching Google font that works just as well as the custom font that they are probably looking for. So here are a few units of measurement that you might be accustomed to seeing, but I want to touch on the differences between them because there are subtle differences that have pretty big impacts depending on how you use them. But the overall difference between M and REM units is how the browser determines the pixel value that they translate into, because that's all the browser is going to do when it sees that M value or that rem value. It's gonna want to translate it into a pixel value that it can understand. So in this first example, we declare for the body a font size of 16 pixels and a span tag with a font size of 20 pixels. So these values will remain the same on the element in which they are set. So it's not always going to be the case with font size properties that you're just affecting the font size. The elements themselves within those containers will actually remain the same with a pixel-based value. So as the font scales, it actually crowds the space of the element. Compared with M's, which by the way are converted to pixels by the browser, we see the effects of inheritance and how it can alter the computed pixel value of an element. So notice the initial font size is set to 100%. This is actually really good practice because some users will want to adjust their visual settings on the browser. So setting it equal to 100% is courtesy for the user to say, hey, if you want to increase the zoom level, that's fine. We're going to keep it at whatever you have it at. So if you see examples with somebody messing with the HTML font size, with pixels, it can be a little bit tricky for them. So 100% is usually best practice in this case. And the default is 1M equal to 16 pixels for default browser settings. But notice now here in our M's example with span and p tag, if we set the span with a font size of 2 M's, that's going to evaluate to 32 pixels. But then if we have a p tag within that, it's going to pick up on its parent, which is going to be the span tag. So therefore, 1M is not 16 pixels anymore. It's now 32 because it's picking up on its parent. So this is where M's can be a little bit tricky. How did that term originate, by the way, M? Yeah, the literal width of a letter M. It was also used to create a word for the letter, which is kind of neat. So it has a kind of dual meaning there. Yeah, a letter actually becoming a word. I thought that was pretty cool.
What's the width of the letter M at what pixel size?
Yeah, it was used, I think, in the 18th century. So whatever the standard was back then. I don't have that value.
Did they have pixel size in the 18th century?
Yeah, this is kind of borrowed from older days, but it's still kind of neat to see that. So, but look at REMS here. What does REMS stand for? We just talked about M, but then what's the R? What's that R actually representing? It's close. What's that? Did I hear another one? No. Root. Yeah, root M. We say it's a more predictable M. So here we have the same three elements, our HTML, which is basically our document. We can think of it as our actual document. The span we've set to 2 rem, which is going to be 32 pixels in this case. But now our p tag within the span, we say 1 rem, and it's actually going to evaluate back to 16 pixels because it's going to go to the root, in this case the HTML, to get its reference. So there's no guessing as to what computed pixel value will be with REMs. But this brings up a good question. When should you use one versus the other? Do you Could you think of a time when you might actually want to use M's versus rems?
If you want to change the font size of anything, it would be easier to do just changing the one M, and then it would change all of its children.
Yeah, you can use that to its advantage. If you have, say, you have a particular module within your application that is kind of separate from the main contents of the page, you could actually utilize M's to your advantage to then be able to pick up on those differences versus having a consistent static approach here with rems. So notice our pixel scales and how they increase in magnitude. And I want to actually explore this for just a moment here. So we'll slide this over. So this is at type-scale.com. And so we can see the associated, in this case, M values on the left-hand side. And we can adjust our base size. So we said that 16 was the default. And this allows you to make several adjustments here, and you can even apply a scale to them. And they're kind of based on music scales, which I think is very neat. And then you can even see them in action via this sample article, and you can actually just tweak this to really see how the differences are perceived. So we see a very extreme scale versus one that's much more gradual. And it's neat because it also kind of gives you those relative values. So that's type-scale.com if you want to explore that a little further. Here are a few other resources too, and these slides will be up today to be able to go through some of them. Treehouse is a pretty good course on this. I'm going to showcase actually one other one. This is another good article. It actually covers. It's a really comprehensive guide on when to use M versus rem values or units. So I'm going to make this available in our resources directory because I think it's a really good useful resource for that. And if you haven't used Google Fonts before, this is where you can go. It's literally google.com/fonts. And you can actually change your sample text if you wanted to get a feel for everything and get your different sizes values right up here. You can sort based on popularity. So here's like an Open Sans, here's Bravado. You can click, add to collection. You can click a couple here. And it'll allow them to utilize those in your applications. Pretty cool, right? You probably didn't know there was that much to just the visual component of the written word, but it's actually pretty neat. Any questions on any of that? So here's what we're going to be working towards today. Looks very similar, right? We haven't made any changes. I actually added an effect. So watch when I hit show less on this bacon, it brings us back up to where we were initially. I think it should be in the starter code today. If not, let me know and I'll push it up so you can see what's actually. It's basically just adjusting the scroll top. It's just another jQuery event to be able to adjust it back to the top piece there. So everything's pretty much the same for us in regards to our blog articles. So let's talk about actual HTML templating systems. Has anyone used HTML templating systems before in any way? Yeah. Something like this? Does that look pretty familiar? Yeah. Selena, did you get to use Jinja in Python?
Yeah.
So that looks pretty similar. So what's actually happening here in this case? Because I see some familiar tags, and I see some common things that Handlebars will be using for us as well.
The percentages on the outside that allows you to specify more logic than actual reference to the context.
Mm-hmm. Little helper pieces. And then in terms of notice the double curly braces. In Handlebars they call them stashes, but just the double curly braces, we refer to those as expressions, which we'll talk about. And it's basically just picking up on actual data properties here to be able to fill in dynamically. So this is a new abstraction layer to connect our model to the view. And this is just a Jinja example that's used in Python. But we say that a templating system is composed of a processor, which is just executable code. So for us, in our case, what we're concerned about is the Handlebars library. So it's just a library coupled with the specification for that information via this template. So the template that we create will contain familiar information, tags, just HTML tags in our case, just like we did with our jQuery template, except now we're going to combine that with meaningful placeholder values. So we're going to be picking up on the actual properties of the objects that we're wanting to use, which is going to be just our array of blog articles. So here's what something like that would look like for us in JavaScript. We declare an actual script tag, typically that's placed in the head section, which gives us what benefits do you think of placing that template inside the head section? Loading before the body of the HTML. What other benefit does placing something in the head section provide us with by default? What's the difference between something that's in the head section versus something that's in the body section? So if we loaded the page with this template, would we see that template? Right, so the benefit of placing this in the head section is that the user will not see the template. With jQuery, we had to have it in the body, and then we had to add a CSS property on it to essentially not show it to the page. So notice how our separation of concerns wasn't really that separate at all. With Handlebars, it's making that much easier. So we can define our template with just a script tag, place that in the head section, and instead of our type being text/JavaScript, we change that to text/ and then we feed it the x-handlebars- template that the library is expecting. So even though we're within a script tag, that script tag is going to be primarily for Handlebars. That's what Handlebars wants. And in in this sample, we have a p tag, just like we normally would in our HTML. It says, hello, double slash name, welcome to double slash location. So these placeholders are not just our typical placeholders. These placeholders are actually pointing to literal properties within our object. So it's expecting that data to be there when we compile it. And we'll talk about compiling in a moment. So the developer, us, we get to create the template that will comply with some context or the model. And all the context points to is a piece of data. So here's an object literal, with a name property and a location property. So the handlebars engine or library will utilize its own method to generate a new HTML block based on the data it's fed. So it's going to take that template and it's going to fill in that template. And then when we're ready, we can actually append it to wherever we want to. And then we can get a result just like this. So there's name with value, location with value. If we go back to our script ID, there's name and location in the double slash. Name and location on our object. And now it's all together. Any questions so far? We're gonna demo this out, so it'll be good.
So, Rick,
Mm-hmm.
you mentioned that React doesn't have a routing sort of thing you use with handlebar, or it doesn't have a template.
Oh, in terms of templating, React does have an actual templating component. So our data or our model layer could also come from a local source, in this case our local data, our array of articles. It could also come externally from an API. So when we move into the concepts of API and getting data from other places, we can utilize this with that as well. So breaking this all down, what this actually really means for us, at least for today, this is funny. This is Horse.js. It's a fake library, so to speak. There's actually a site called javascript.horse. It's hilarious and sometimes true. It's kind of become a place for developers to go to get a good laugh and say, yep, I get it. I understand what's going on here. This is pulled from its website. You can literally just hit refresh to get a whole bunch of just one-liners or just kind of tidbits about development in general. Yeah, and I love that horse image too. It just cracks me up every time. Remember this? Quite brittle and error-prone, yes? So today we're going to actually get to clean all of this up. So our toHTML method that we spent all that hard work on will now be reduced to just a couple, maybe 3 or 4 lines. But again, we wanted to showcase the kind of the evolution of jQuery and how it was kind of the one tool for every job. And then as we kind of started utilizing more MVC architecture, we were able to abstract away with different tools, such as these templating engines like Handlebars. So there are other systems that utilize templating that are very common. Angular uses a very similar syntax. You might hear interpolation. in the case of these expressions. So again, just another technical term, but when you break it down, it's just trying to evaluate what these expressions mean. So it's not that we're displaying the properties themselves, but we're trying to pick up on those values. We care about the values, the key value pairs. We're just wanting to get the values from those properties, such as who and name, if those were properties on an object. But all of them try to solve just this one problem: how to structure web applications. So let's do a brief demo in today's class folder on the lecture repo. If we're in the class 4 folder, lecture-301D7, class 04, templates, it's going to be in the lecture folder. We're going to be inside of the demo code. So this will be in the lecture repository and not the lab repository. So there should be one titled that's titled lecture-301D7. There should be a repo with that name. You might have it cloned down already. That'll be for our lab today, but there should be one. Let's see. Do you have GitHub open up on? So let's change this path. We'll take out the dash and we'll say codefellows /. We'll just add a / to replace that. Yep. Yep. Let's go there. And we're in the class 4. That's the difference here. And then lecture demo code. Handlebars. Yeah. You might check to see if it's in your directory already, in your parent 301 folder in your terminal. Repo, that might be it. Yep, there it is. Okay. Okay, so we're starting off in the index.html. Is there anyone still pulling that up? So here we have a neighborhood template, which currently, this is the page. If we run this with live server, we just have an empty neighborhood stats field. So we want to be able to populate that. And in our data set, we just have a collection of 3 fake neighborhood data sets: Fremont, Ballard, and Wallingford, with similar properties on each of them, all within this neighborhood data set array. So in the index.html file, we're currently in that head tag. So let's add our template for handlebars to utilize. So we're going to start off, we're going to give it an ID. We're going to call that neighborhood-template. And then we're going to set the type to text / x handlebars template. And now within here, we can build out some familiar components, such as with an H2. But now we're going to utilize some expressions with the double stash, which when we compile and then append to the page, they will get interpolated into the actual values that we want. And we can mix in different text here with that. It's no problem. Add another p tag for the population. And we'll add one more p tag for the year that it was founded. Thank you. Now I'm going to do something really crazy. Triple stash. What is going on with that triple stash? Why do we do it for the body and nothing else? Yeah, it's gonna. You might see some people say like escape those actual those tag pieces here when it's parsing through the text. So if we hadn't done the double stash, or if we hadn't done the triple stash, we would literally see the p tag display on the page, like the actual tag itself. So we utilize the triple stash to be able to pick up on that HTML for us and actually render the HTML. And then here we close our script tag. So far, so good? So the main components here again are that we are defining a script inside the head. We're setting a meaningful ID, preferably something that has a little template associated with it, so we know what that script is doing for us. And then we specify the type that handlebars expects with the text / x handlebars template. And then we can fill in any HTML we want with the properties that we want to pick up on. So let me clarify that if we didn't want the founded property to be in our template, we don't have to have it in there. We don't have to pick up on all the properties. So just because we get a data set back doesn't mean we have to utilize every single one. The template will specify what it is that we want to actually render to the page. Okay, so the next part is going to be inside of neighborhood.js. I got pretty wild with my naming conventions because I wanted to be very explicit. So this is an extreme use case of calling your pieces what they actually are. But it's a very similar format other than that, in that I have a neighborhoods array that I've declared at the top. Here's my constructor function, which is picking up on all the properties dynamically via this for in loop. So no matter what the properties are, we just want to grab them all. So I can specify for whatever key in that object, we're going to set the new neighborhood, the new instantiated neighborhood's key to whatever the object's key is. So notice the bracket notation here. This is it's a new way, because if we try to use dot notation, it would be confused because it's actually trying to pick up on a property that's already existing. So the dot notation is essentially another form of the getter mindset and not actual setting. And here's our familiar toHTML method that we were able to write and access on the prototype. So what we want to do now is we want to set up to be able to have handlebars utilize the template that we just wrote. So we can do that in a couple steps. We define the template. And we want to be able to pick up on the literal HTML from that template that we defined. So now the source variable will contain everything in here. On the next line, we get to actually utilize handlebars. And specifically, we get to use the compile method. And the compile method wants or it expects some form of HTML. But we can also think of this as a template function. And the reason I say that is because we actually haven't done anything yet. Handlebars.compile source is only updating, or it's going to return to us a new function. However, when we're ready, we can actually pass in our context object. So the reason I put this aka template function is because the result of handlebars.compile, utilizing our actual template here, it returns to us a new function that we save inside of template. And so when we're actually returning on line 11, we're getting the result of invoking template with this. Let's save everything so far. And take a look at our page now. So there we see our properties with only a few lines of code in our 2HTML method. And notice our body now is actually displaying the proper HTML visual components here with some bold text and some italicized font. All right, let's go back to this though for a second. And by this I mean literally this. What is this in this case? What do we think it would be? If we save this, and by this I mean the file, and we expand our console, look at that. We have our 3 neighborhood objects. What about template? What if we just tried to log whatever the template was? It's a function. Which is why we had to invoke it. It was expecting the context object of this, which was just the object that actually called it, which happens right here. So again, this is verbose, but I did it on purpose to leave no doubt as to what was actually occurring. So we loop through our initial data set on line 14, and we push to that empty array on line 1 the result of stepping into the constructor function for each element in our initial data set. And now once we've built out our neighborhoods array based on that constructor pattern on line 18, we can run another for each to then take each element inside of that. And we're going to append the result of everything I've just highlighted right here. We're going to append that to this jQuery selector, this neighborhoods ID. So let's go there. Here we have neighborhood stats, which is what we saw initially on the page. And here's our neighborhoods ID, which is nothing more than a section. So it's as if we were literally filling this out all right in here. Handlebars is doing that for us. Now, if I'm confused on those steps, the handlebars documentation is actually pretty good. And this is handlebarsjs.com. And it provides a nice little getting started right here for expressions. If you need to get a refresher on what the script template looks like, they have that. And then when you're ready to compile, they have broken that into a nice little step pattern as well. So you can kind of take it through each piece, line by line. And again, they talk about the context object, which is something we're already familiar with. And we have to invoke our template with that context object. So if you ever receive the error with handlebars that it's expecting some sort of a string or value, it's typically because the context object was not passed in properly. So just a heads up on that piece there. Another really good resource is tryhandlebarsjs.com. It literally has all of the pieces that you can experiment with right inside of the boxes. And here I've built out an example of what you can do if you have nested properties. So notice we have a body property in our context object here that has its value another object, which has a name property. So we have this nested set, but look over here on the left, we were able to, with our handlebars expression, we were able to pick up on that with just simple dot notation in our expression. So it's another way of actually going about retrieving the value that you need if you have a complex piece of data that you're working with. Handlebars also provides nice block expressions, something that's a little bit of a bonus for us. But there are also nice if helpers that you can actually come across. So the data that in which you're going to be interacting with will not always be clean or sanitized, as I like to say. So there may be missing values. But the handy thing with some of these block helpers is you can actually check with some logical expressions to see if there are properties that actually have values. So if I am retrieving a data set and there are a couple title properties that don't have any values at all, then it will bypass that and not render it to the page, which is going to be a much better user experience. Any questions? Thumb meters for handlebars? It's okay, you can be honest. Right here? In the middle? That's okay. If you're in the middle, that's really good. Really good. Because it's something new. It's previously unfamiliar, and that's okay. No one's expected to know everything about handlebars after today. It's just every concept that we talk about each day is just kind of designed to showcase something new, and how you can go about learning that and utilizing this new approach. Okay, so we're past the top of the hour. We'll take 5 minutes, and we'll come back and we'll do a little assignment prep. Okay, so I'm going to return to record mode now. Anyone still getting the new branch checked out for today's assignment? Okay, so in the index.html file, we've hit our first to-do in that we need to complete a script tag to house our handlebars template. So we want to give that a meaningful ID attribute, and we don't want to forget to specify the type. So I'll walk through this part, but I won't actually create anything because I want to give you the opportunity to get some practice in. So we're just building out an article like we normally would. Here's our byline. The address and name of the author. Okay, I'll fill in one. Close out our header. Create our section for the article body. Then we close out the article. And we'll close out the script. So it's looking a little bare. So for lab, it's going to be you and your partner's responsibility to fill these in with handlebars expressions. And we've completed one with published status, which I don't think is actually a property on any of our current article objects. But we're gonna talk about that. So far, so good? If we're ready, I'll take us over to the next section. So I'll save this. We're going to go into article view, take a look here for a moment. Here's our populate filters, handle author filter, handle category filter. Here's our main nav. There's our set teasers. Pretty much unchanged. Now back in the article.js file, with our article.prototype.toHTML method, we hit this to-do that says use handlebars to render your articles. Select your template from the DOM, and then compile your template with handlebars. Here's a note that says if your template will use properties that aren't on the object yet, you can add them. Since your template can't hold any JS logic, we can execute that logic here. So the result is added to the object as a new property, which can then be referenced by a key back in our template. So back in our template, that key or property was publish status. And now back in article, here we have publish status. And we're using what's called a ternary operator, which is almost like a function in that it wants to return a value. So think of it like asking a question. It's going to see if there's a published on property, and if there is, it's going to set that value to everything between the question mark and the colon. If there isn't a published on property, then we're going to assume that it's still in draft mode, and we can set the value to be draft then instead of an actual value for being published. We'll cover this again tomorrow when we actually go through a form building exercise. But just note that you have the ability to set explicit properties, because when we call toHTML, the this keyword is nothing more than the object that's calling this method. Therefore, we have the ability to utilize that, to be able to add different properties based on existing properties. And if you need clarification on the toHTML part that we filled out in earlier, you can check the demo. You can utilize the handlebars documentation. But essentially, we're just going to be picking up on what that template is and saving that, and then being able to use the handlebars.compile method to then be able to utilize our template to then render everything to the page. So if we scroll down here, we're still achieving the same end result. Let me add some space. So ultimately, we're still going through our articles array. And for each article object, we're still going to be appending the result of the article instance calling the toHTML method. So don't forget to include your return statement in here. Any questions about what we just did or discussed earlier? How do our thumb meters feel about handlebars in general? probably the majority of the work is going to come from just filling this in. But I wanted to live code this so that we could get a sense for the structure. But really, today's focus is just being able to pick up on the expressions, how we use handlebars expressions with the double stash, and how these point to different properties. So when determining what we need to fill in for each of these empty spaces or blank quotes, or even in between these elements, we can always look back at our original data set to determine what properties we have, to then be able to fill out everything in here. Yes, Stephen?
So I'm just curious, are we able to, like in that script tag, load the external file that contains just the HTML of that template?
So you're asking if we could take this script template?
Yeah, let's say we have a folder template.
Oh, like a folder of just templates.
And then say like article.html, and we load that to that script tag, and not to put it like inside index.html.
I see what you're saying. So you have it separate from the
Yeah.
index. Yeah, I know there's a way to do it. I believe there's like a handlebars extension, or not an extension, but a kind of a resulting like a file format where you can actually house a lot of handlebars expressions or templates rather. In this case, we're only going to be utilizing 3 at the most if we do the stretch goals today. But I have seen situations where there are like a literal, like a folder like you mentioned, that have all of your templates housed neatly in there, which is definitely the approach that I would take. Yeah, it's a good question. And let me take us back to, I want to be in article view. So the stretch goal, if you're feeling up for it, would be to refactor this populate filters method to utilize handlebars. So for each filter type, we could create a new template and then build that out. And there's a really, really dynamic way that we could do this by writing or refactoring one of our functions to accept as a parameter the actual template ID. So we could just pass in a template ID, and based on that template ID, we can build out the new handlebars template with the compile method that we have with handlebars. Any other questions? Quick check again before we break for lunch. It's okay if you're here. Just a little bit of, or there, yeah. Just a little bit of practice. Initially when I heard about handlebars, I was like, no. But with a little bit of practice, it'll be very, very helpful, I think. I'm gonna find out the times for presentations for the JavaScript classes tomorrow, and I'll let everybody know. So there'll be 2 presentations. So we'll try to make it work with our schedule so we can let everybody get a chance to see those. Okay. We'll break for the